Welcome to another episode, a short on a system called FeH2O Loc. Now, this system in this short features two engineers that were part of an expert's session earlier. One of them, Matt Janes, 35 years experience, is a senior designer with Ishwood. And we're going to flow right into an edit with a 35-year hydrogeologist who's considered top of his game in Vancouver. I'll talk about FeH2O Loc relative to its ability to replace secant walls, and it has advantages that these two fine engineers will comment on. And pay particular note to the fact that this is a drained system. There's two 5-inch layers of shotcrete. The shotcrete is designed with a special fang feather edge, effectively two quilts with a long tapered joint, top, bottom, and side. So the shotcrete can be applied single layer. I did this system at HCM, and I did that for temporary shoring, but now I've made it into a permanent waterproofing system, and it has a lot to do with the application in shotcrete of FeCS Meta Mix, which is crack-free and waterproof. So 2 layers of waterproof shotcrete, properly prepared with wood floats. And that system is on a bypass pile, which allows me to eliminate the filler piles, and typically very applicable to type 1 and type 2 soils. In any soils that are fill-natured, I would add in a middle filler without changing the intent to replace waterproofing, and have a drain system which lowers anchor loads. So when you take the hydraulic pressure off a secant wall, you have no leaky anchors with our system. You have a completely waterproof system. So you can save the cost of the waterproofing and save significant construction time. It helps developers, it helps housing. Anyway, without further ado, we'll go to the Matt Janes podcast. With FeH2O Loc, which we believe are going to change the nature of the secant industry in North America. And we'd love to have someone like yourself who probably is capable of carrying some of these designs into the States. Do you have, does Ishwood has the ability to do work in the States? Or you certainly know a ton of people, right?
Yeah, sure. I think what's interesting about that technology is, that it can provide a constructible, thin, if you will, system to create a waterproof foundation. And what's interesting about when I say thin is, a secant wall, a slurry wall, et cetera, these are 600, 800, 1,000 millimeter thick systems. Very constructible, but they occupy a lot of real estate, and they're not perfect. They're generated underground. And just as an example, if you went to a concrete formwork guy or group and said, "Oh, would you please create a waterproof wall for us? And we'd like it 40 feet high. And we'd like you to put a cold joint every 2 meters, which is what you get in a slurry wall, or every meter or less, which is what you get in a secant wall." Well, the concrete suppliers would turn to you and say, he or she would say, "You're crazy. You can't get a 100% waterproof wall with a cold joint in it. We have to do X, Y, and Z, and it's a high risk, and we don't want that risk." And yet this is what foundation people are being asked to do all the time, to create waterproof barriers with cold joints that we develop 40 feet underground. So the H2O Loc is really interesting because what happens, we excavate down in sections, open up the wall, provide a groundwater collection system in behind it, and then using a unique concrete product in the open with workers that have excellent access, create these panels and make a truly waterproof system, and then can come back and put admixtures on or other layers of such a H2O Loc product and create a waterproof system. And it's more constructible than these other more physical large machine type foundation systems. So what I think it does is it combines the brilliance of access as you excavate and create the panels with a superior product that can make up for this problem of cold joints. And so that's, I think, what's really interesting about what you're doing and how it's going to be used in the future. Now, is it for everything? No, absolutely. No tool is. You know, if you've got a lot of water in the ground, you're going to have troubles controlling that water when you're making your panels, et cetera, et cetera, et cetera. But, you know, it's got phenomenal application in numerous systems that are going to make it very, very interesting and takes up less footprint with high quality workmen and product. You're going to achieve your goal and create waterproof basements, which is, and especially with the opportunity to eliminate what is now, you know, we put in a foundation system and then they build a whole new wall in front. Well, you're going to eliminate that wall. What a savings that is. And again, money or the cost of those walls is, while significant, that's not the impact. It's the schedule savings that you create by not having to do that wall and losing 7 days every single, you know, piece or parking slab. It's got some real phenomenal potential.
I look forward to asking. You'd probably be one of the first guys that I would ask about slab to wall connections and whatnot. And you're right, it can go that way. You know, a 2-acre bathtub, 2-acre raft slab, let's say in Toronto, which is a misguided attempt at regulating something on a treatment plant, it's going to save $10 million for a developer. And somebody who's leaning in, but is our friend Tobin, Jerry, by the way. Mm-hmm. He's caught wind of it and he's tired of the 20 Secant prices he's facing in Toronto. So by making it a select opportunity with firms that have good engineers and good equipment, I think we're going to have a conversation tomorrow morning, and I'm quite sure that Tobin will see that advantageous in Vancouver as well. So we're just going to go per province, and we're going to be a fraction of the savings on one job. They'll pay for a 3-year right to my patents, a group of 6. So I wrestled a lot. I sprayed it around and asked people's opinions, and I was a long time creating. I think in 2 years I did 12 patents, but you know, my thing is I'm very concerned about earth honoring systems, and that's what drives me. And I think you naturally get it. You know, when we look at our choice for engineers, Isherwood is always my first choice. My point is that Secants are not only wasteful, but they're the only thing people reach for. They don't stand back and do a bit of value engineering at the start, which is key to these projects, to meet the owner when he's trying to arrange his financing or sell his condos and say, you know, you might well run a value engineering phase, which is only about a week in a formal Save International sense. But, you know, we in Footprint and people like yourself can pull this together in a phone call. And, you know, somebody with 40 years experience like yourself, it would be wise that people get to know you, and hopefully you'll be better known by being on my podcast. But when you dam up the water on Secants, you're automatically giving away the opportunity to do a shotcrete solution, which naturally will drain the soil by the time you get down to the footing.
Yeah, and I can show you some really good data that as the excavation was going ahead, the pore pressures were dropping always just ahead of the development, which shows that the concept of depressurization with your shotcrete will work. I mean, I've got the data to show it, to prove it. It's a more elegant solution, and it's certainly cost effective. It reduces the time required to do the excavation because you're not waiting around for soils to depressurize. It's a win-win for the owner and for the contractor.
You know, one of the owners that I'd like to mention would be the government, and particularly these large transportation projects, because when they automatically reach for Secants, then they've got a whole wide body of, and they're assuming they need thick walls for whatever history caused those, and a thick raft slab. And frankly, those jobs, I'm quite sure $1 billion transit project could be done for half that money. And I don't see why we can't aim for that. Now, to go back to the large engineering house, a lot of those guys get 8% of hard cost. and I like to turn the knife a little bit on them here,
Yeah.
because they don't reach for the solution other than what they did last time. Well, why should
Yeah.
we change it? The details
Yeah.
are already there, but it's their job to redesign it and explain to the owner, we deserve as much fee because we just saved you money.
Exactly.
Like,
I agree with you, Martin. It is a little bit of a bugbear with me that some professions get paid as a percentage, and I would include architects in that, whereas the likes of me anyway, it's usually a fixed fee, and that's it. But engineers, if you go working with a geotechnical engineer, he or she is quite happy with a factor of safety of 1.1, 1.2. I mean, some of those 600-700 meter high slopes, they actually designed them to fail. So the civil engineer doesn't have that luxury. And they've got to design to usually 1.4, 1.5 of a factor of safety, which tends to be an over design. And I think, as you say, if they could step back initially and see, where is the risk, where's the reward, and modify what had been a previous project for this new project to better suit the actual conditions, rather than try and shoehorn in a previous solution that might not really be appropriate for their next project. Again, that's where
maybe there has to be regulation chain. I mean, if our government wanted to save money, then they should mandate. And I think the DOTs in the States are a little better at this, that they would have a larger value engineering industry. And we're just locked in with these large consultants, I think, but nonetheless, there's a lot of small, mid-sized guys that deserve a shot. And my goal is to reduce the size of in Toronto, subway walls are 1 meter thick. Now they're shotcreting them, which is great, but that is crazy when you look at how can it possibly be that low? They got a caisson wall behind it, or secant wall. So that secant wall in my system, and I know you'll connect the dots quickly on this, we weld tabs to that pile. We don't debond that pile with waterproofing. And thank you very much. Subscribe to my podcast. We're basically offering insights every podcast to companies that care about our earth honoring systems objectives. Anyway, take care and trust you will share this and that we'll have success with what is a patented system in the USA. And one more added note, we combine it with FeBTU cells, which are arguably the most efficient geothermal done with a caisson machine. And that helps us handle any leakage that could possibly make it to the bottom of the excavation, because our goal is to eliminate raft slabs and eliminate and reduce rebar. Thank you for listening to the short. All the details of this FeH2OLoc system are on footprintengineering.ca. My mobile number is 519-240-6334. And my email is martinh@footprintengineering.ca. So we have 10 patents, and all of them lower CO2 in the built environment. Those were great comments by Matt, that there's no vertical construction joints, and by Shane, that when you drain it and work with a shotcrete system, which they do in Vancouver all the time, you're increasing the effective stress of the soil. So the behavior of the anchors improves and the load on the anchors is less. In any case, have a great day. I love you all, and call anytime.